Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to look at a May-June 2022 question paper, physics. All right. And now we're going to go through multiple choice questions. I don't like doing a question paper whereas I ignore the multiple choice questions. Okay. They are very important. They are the 20 marks that one might be in a position of getting. Right. So let's dive into it. Now, it says now to us 1.1, a bucket is at rest on a table. Okay, a bucket, let me draw a bucket there, is at rest on a table, right? Okay, there is our table there of, yes. Okay, now they say to us, which one of the following is the reaction force, okay, to the weight of the bucket as described by Newton's third law. Now remember Newton's third law, we have action, reaction. It is an action reaction, right? But now we need to know which one is an action, which one is a reaction. Now when when I exert let's say it is okay here. I have a wall. Let's say I have a wall here, a wall like that, and this is me. Okay, I am punching the what? The wall. Now, the action, it is me punching the wall. This is the action, okay? The action, I'm punching the wall. But now the reaction is that the wall will exert the same force towards me. Okay, I will feel pain. Why? Because now we assume, actually, we don't assume. The same force that I'm exerting towards the wall is the same force that the wall will exert towards me, right? So hence also I feel pain. So this is what I call the reaction. In this case, let's see. The action is what? The reaction force to the weight of the bucket. Weight of the bucket is the action. But now, what is the weight of the bucket? Remember, weight it is the force that the earth exerts on the bucket. Remember, you have weight because it is the force that the earth rather exerts on you, right? So the weight is the force that the force rather, not the force, the force that the earth, okay, exerts on the bucket. Now this is the action. Now what is my reaction? My reaction will be the reverse. Now it will be the what? The force that the bucket, the force, can you see I'm starting with the force? The force that the bucket exerts on what? Not on the weight, on earth rather. Okay? On earth. I believe you are following. So option of that some sort, I wanted a reaction. So it is the force of the bucket on earth. So force of bucket on earth, here is it. Here is it. So B is the most correct answer thereof. I hope I explained that thoroughly. Okay. Sorry. 1.2 says to us, a ball is dropped. Let's say a ball is dropped from a small height. Let's say here is our small height. Okay. Remember when our ball is dropped, its initial velocity is 0 here. Okay, let's try to read the statement. All of the statement. Let's try to read all of the statement. A ball is dropped from a small height above the ground. Okay, it's dropped. Very important. It tells you about the initial velocity. Ignore air friction. Very important. The following pairs show physical quantities associated with the ball while it is falling to the ground. In which one of these pairs will both quantities change? Okay, while the ball is falling. Now let's start here. The ball was dropped, right? To until it reaches the ground. Okay. So here the initial velocity was 0 because now it was dropped. But here the what? The velocity final will be the maximum velocity because it will change, right? So now which one? The question says now to us, oh, so there is no friction. If there is no friction, it means mechanical energy is conserved. Okay. So now which of these pairs will both of its quantity change? Now make this simple for you. The quantity that will change, it is the one that has velocity. Since the velocity change, anything that has velocity will change, anything that has height will change. Why? Because the height changes from whatever. Here the height, it is 0. Let's say here height, it is maximum. Can you see that? So let's try to figure out that mechanical energy will not change. Why? Because it is conserved. Okay, mechanical energy it is conserved. It won't change. It won't change. Okay, weight weight will not change. It is just the mass as well as the gravitational acceleration. And remember, for a free fall, the gravitational acceleration, it is 9.8 meters per second squared. Does not change. Kinetic energy, anything that has a velocity, remember it has a velocity half mv squared, so this one will change. Kinetic energy has velocity, will change. Momentum, it is P, it is equal to mv. It has velocity, it will do what? It will change. Let's see, gravitational acceleration, it is constant, 9.8, it won't change. Kinetic energy will change. Okay. Gravitational potential energy, yes, gravitational potential energy, which is EP, will change because the height will change, right? But gravitational force of gravity will not change. So can you see now the correct most answer, it is what? B. B, it is my correct most answer the off. I believe you are following that. I strongly believe you are following. Uh so the answer, it is B there. Now, a ball is dropped from height h and strikes the floor with momentum p here. Ignore air resistance. So now it means every time when you ignore resistance and what it means, mechanical energy, it is conserved now the off. Okay. Therefore, uh, let me. Therefore, the ball is now dropped from height to h. Which one of the following represents the momentum with which the ball strikes, or with which the ball now strikes the floor? You want the momentum of this height of this ball, right? Now let's try and see the momentum for here. So I want you to realize something here. It is dropped from this point. Okay, from this point we have ep. Okay, ep is equal to mgh from this point, but there is no kinetic energy because it is dropped. Velocity, it is 0. But as we go down, this mechanical potential energy will be converted to what? To kinetic energy. When something is dropped with an EP, as it falls down, the EP decreases. All right, the EP decreases. Why? Because the height also decreases. But now the velocity increases, increasing the what? The velocity. At this point, there is no EP. Okay, here there was no EK. Okay, but here there will be EK. Can you see that EP was transferred to what? To EK. Okay. Yes. Now let's try to find the velocity thereof. You can use a vertical projectile motion. This is VF and V or VI VF. Let's find a VF. Okay. We're gonna use this formula VF squared. It is equal to VI squared plus 2G, which is our acceleration change in Y. Okay. Now remember this is 0 here. This is 0. So when I want VF will be square root of 2GH. Okay, even if you were to use a mechanical energy or what, remember I said here, sorry, we have EP which is equal to mgh here, but now this EP will be transferred to EK. Okay, this EP will be transferred to EK, but what is EK? EK, it is half mv squared. Now can you see that I can cancel the mass and mass, and now I can multiply by 2 so that I have v squared, it is equal to 2gh. Then when I want a v, I can say v it is equal to what? Square root of 2gh. So it is the same thing. Okay, whichever that you use. Now that I have a vf here, it means my momentum is equal to p, it is equal to remember, p it is equal to mass divided by it. This one, it is p1 actually. Okay, the first p1, I'll call this p1 and this one will be p2. But what is my velocity thereof? My velocity, it is what? M. Okay, which is still equal to m. What is my velocity? My velocity is square root of 2gh. Okay, so this is my momentum one, my first momentum. Okay, Now let's try to find a momentum B or momentum 2. We want the momentum here, right? Now let's apply the very same analogy again. Remember we said here the initial velocity is 0. Then let's try to find Vf, okay? So it's going to be Vf, it is equal to Vi squared plus 2gh, okay? But now I still repeat, this is 0. Therefore now my Vh, my Vf, okay, let's try to substitute Vf squared, it will be 2g. But now what is my height? My height, it is now how much? 2h. Can you see that? Let me just instead multiply here, multiply by 2h. Now can you see that it's gonna be 4gh, okay? 4gh. So now when I square that, it is basically square root of 4gh. But now I want to express Vf 4gh. I want to express Vf in terms of 2gh something. So I can say this is the same as saying this is 2 multiplied by 2gh. Okay, it's still the same. Then and now take out this part as square root of 2 multiplied by square root of 2gh. This is the same thing. Okay, this is my V final. Okay, now let's find momentum 2. Now to find momentum 2 is still the same mass than the velocity. But now what is its velocity now? The velocity is this one. I'm going to say mass multiplied by square root of 2 multiplied by 2gh. But now I want you to take note of this. If I were to rewrite this as square root of 2, then m square root of 2gh, what is this? What is this? Do you still remember this? Yes. Remember, this is what I calculated before. So this is momentum. So this is the same as momentum 2, which is what we are looking for. It is equal to square root of 2. But what is m square root of 2gh? It is p1. So it is the answer. It is now square root of 2p instead, because that one, actually they said the momentum, it is p here. Okay, yes, I can say it is p. So the final answer, it is square root of 2, square root of 2p. Where do we have that? Here. The answer is B there off. Okay, the correct answer, it is B. Let's move on to 1.4. Object X exerts a force on object B. Sorry. Object X exerts a gravitational force on object Y, okay, with a distance between the centers R. Now we have object X exerting a force on object Y. Whenever their distance between their centers, it is R, their force, it is F. So it means now we have something like, okay, remember we use this formula to calculate this. F, it is equal to G M1 M2. Instead, I'll say Mx My divided by R squared. When their radius is R, the force that was exerted was F, right? Now let's see. The R is now doubled. Now what happens? Remember, F is directly proportional to the masses and inversely proportional to the R squared. So now let's see. Let's find F nu. F nu. F nu will be the same quantities there. They did not change. Mx, My. But now what happened? They doubled the distance. So it means now my distance will no longer be R, but now will be 2R. Okay. When they double R, it is 2R. But don't forget to square that, okay? Now, when I simplify my math here, I get something like G mx my divided by 4r squared. Okay? Okay? But now, what is this? Remember 4r squared. What's this? This is F. Okay? When I highlight this, gmx, what, and R, and only R, it is F. So it means I can take out this part as, remember there is 1 here. Okay, so this is 1. This is equal to 1 divided by 4 What is that part? That part, it is F. Okay, yes. So the most correct answer now, the of, it is A. In this particular case, the of. The most correct answer, it is A. Okay. Now let's move on to 1.5. A force F moves an object P from X to Y along different path X to Y. Okay. The force done by F is moving an object in the same for both. Okay. Which one of the following can be used to describe F? Now, can you see that this is something like on an incline? Okay. On an incline. So there is no applied force, there is no nothing. Remember, on an incline, gravity pulls the objects down. Okay. So there is no tension. Normal force causes the object to move up, not down. No friction. The friction will not be the same. Okay. Then gravitational force is the correct answer. The of D is the most correct answer. Now, 1.6, which one of the following can be explained by the Doppler effect? A stethoscope is used to listen to a person's heartbeat. No. Remember, medical use, we use a, what is that instrument to measure a fetal heartbeat? Okay, I have forgotten about that one, but it measures the fetus heartbeat, but it is not a stethoscope. That one you can see from your notes. An echo is heard when sound waves are reflected. No, this is not a Doppler effect. It is rather sound waves, light, and all. The spectrum of light from an approaching star is shifted toward the shorter wavelength. Yes, approaching star, higher frequency. Yes, this is Doppler effect. Okay, this is Doppler effect. Sound intensity decreases. Remember, on Doppler effect, sound does not change. Sound remains constant throughout. Okay, whether the object is moving or towards or away, what changes is the the wavelength as well as the frequency. So the most correct answer is C. This one wants you to know your theory. 1.72, oppositely charged points move towards each other. Let's see. Let's say this is positive, say this is negative. Okay. Now, as they move towards each other, I want you to see something. Now, okay, let's say here, this is R. As they move towards each other, I want you to realize that the R, which is the distance, what happens to their distance? Their distance decreases. Let's say their distance decreases to 1 R, half R. Now, remember, F, it is a F is the inversely proportional to the distance. Okay. Remember, if I use this formula, you can see very well. Okay. When R decreases, what happens to the force? The force increases. Similarly, when R increases, the force decreases. Okay. So now what happens is that let's minimize let's decrease our R. When we decrease our R, it's gonna be maybe half. Okay, this is R squared. So when we do that, it's gonna give us something like GM1 M2 divided by 1 divided by 4 R squared. 1 divided by 4 can be written as 4 M1 M2 divided by R squared. This is not the same as this one. This one was only 4. So we said 1 divided by 4. But for this one, it is 1 divided by 4. So the 4 goes to the top. So can you see now our force has a new magnitude of 4. So our force increases. But now what happens to our force when our, remember, we say our force will increase, right? But remember, F it is equal to ma. Our force is directly proportional to acceleration. Okay. So now if our force increases, uh, our acceleration will also increase. Let's see. Constant velocity, no way. Constant velocity means there is no acceleration. Decreasing velocity, there is no way it's going to decrease. Constant acceleration, no. Increasing acceleration, yes. I hope I explained that. 1.8, which one of the following phrases describe EMF? Just know your definition. Maximum power, maximum energy supplied per unit charge. D is the most correct answer. Charge transfer per unit time, no, no, no. Okay, know your definition. The graph, the graph below represents the output voltage versus time for an AC generator. Okay, the speed. Okay, you can see now the full wave, or rather the, yes, one rotation takes 0.4. Okay, one rotation takes 0.4. Then maximum output voltage, it is 200, minimum it is um, negative 200. Now I want us to see something. Now the speed of a rotational what is doubled. Okay, now remember, when something is moving like this, okay, let me try to redraw that. When I increase the speed, it's gonna be it's gonna move faster. So it means the time taken to complete, let's say, a wave will be shorter, because now when let's say you are running from this point to this point, it is 5 meters, and you are running at 10 meters per second. So the time you're gonna take, it is something like v is equal to, the time will be 0.2. But now let's say you increase the speed to 20 meters. When you increase the speed to 20 meters, it's going to be 5 divided by 20, which is 0, huh? 5 divided by 20, 1 divided by 4. Here what's happening? Oh, here it is 0, 0.5. Sorry. Then here it will be 0, 0.25. Can you see now the time will decrease? Okay. Now the time, if now it is doubled, it means your time will halve in this case. Can you see? I doubled my speed. Okay, what happened to the time? It halved. It always does that. So time for one rotation will be half of that to complete one rotation. One rotation is 0.04. So the new time will be 0.02. Okay. Then now what happens to the output voltage? Now I want you to see something. When you move faster, the output voltage will now double also. Okay, but now as it doubles, the time taken, can you see? Now oh, sorry, let me repeat that. The peaks now double. Okay, the peak output voltage will now double, because now you are taking out more energy now. Okay, so it means we're gonna be having something of this sort again. Can you see it takes everything in half? Now I want you to use something. It completes the first full wave. Remember, full wave, it is coming and like this. Okay, this is what we call a full wave there off. Okay, so now the one rotation was done here. So hence I said the time will be 0.02. Can you see that? But now what will happen to the output voltage? The output voltage will double, will become 400, and they will become negative 400. So the most correct answer there of it is A. Okay, yes. Remember, for a quick summary is that when you increase the speed, you will increase the voltage, but you will decrease the time with whatever effect. If you double it, if you double the speed, it means you will double the voltage, but it means you will do what? You will halve the time. Let's say now you halve the speed. What will happen? You will halve the voltage, but you will double the time. So can you see that? Let's say I have 5 times speed. I multiply my speed by 5. It means my voltage output will be 5 times that. But now what will happen to my time? It will be 1 divided by 5 of whatever time it took. I want to believe you are following. Last question. Now a photon of light, okay, a photon of light of energy 2x joules is shown onto a metal surface with work function of x joules. Which one of the following represents the maximum kinetic energy in joules of the electron ejected? Now, remember the formula says energy of a photon, it is equal to a work function of a metal plus maximum kinetic energy. Okay, so now I'm giving what? Energy of a photon, which is 2x. Then I'm giving its work function, which is x plus ek max. Now they're off. So what do they want? The full maximum kinetic energy. So my ek max, this one was easy. You just take this to the other side, it becomes x. So the most correct answer in this case, the off was C. So yes, thank you very much, folks. That's all for May June 2023. Let's meet on question 2. I hope you found these multiple choice questions very helpful and very beneficial for explanation purpose. Thank you.